as we're looking at multiplication, it is nice to see that there's a couple numbers that have some very special properties with respect to multiplication. And a lot of times this will be remembered as a rule, but it is a good idea to remember why it's true based on the meaning of multiplication and not just memorize rules without having those rules be attached to some meaning. So we'll look at 12 times 0, okay? And a lot of you might actually remember that any number times 0 is 0. So 12 times 0 is 0. And rather than remembering it as, well, anything times 0 is 0, the question is, why is anything times 0 equals 0? Okay, so rather than looking at the bigger question of why is anything times 0 equals 0, we can talk about this specifically in the case of 12 times 0. So if we go back to the meaning of multiplication, multiplication is actually initially brought up as a repeated addition. So we can think of 12 times 0 as adding up 12 copies of 0. So it's 0 plus 0 plus 0. And I'm going to continue this. Okay. So you think about having 12 bags where each bag has 0 apples in it, then altogether you have 0 apples, okay? Or another way to think about it is we're adding up 0 copies of 12. So this is kind of like, I can do this like adding up 12 copies of 0. If I was to write up 0 copies of 12, it's like an empty addition. So I can't actually write an analogous thing like that. But in the thinking about like the bags of apples thing, this is like if I can imagine that I have bags of 12 apples, or 12 is a dozen, so you can think about a dozen eggs, and I have 0 cartons of a dozen eggs, that means I have 0 eggs. Okay? So the rule that we can write about multiplying numbers by 0 is any number times 0 equals 0. But rather than remembering this as a rule, again, I want you to think about like why it's a rule and thinking about the meaning of the multiplication. 12 times 0 is adding up 12 copies of 0 or adding up 0 copies of 12. Okay, I want you to have some sort of like concrete meaning to that multiplication rather than just quoting a rule. Okay, 1 times 39. Again, we could think of this as adding up one group of 39. So it's just basically like that. Or it's adding up 39 groups of 1. So 1 plus 1 plus 1 plus 1. And I'm not actually going to write all of the ones. So there are 39 copies. And in terms of the pictures, you can go, there's one group of 39, or you can go 39 groups of 1. 1, 2, 3, 4, 5, 6, dot, 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 dot. So if this is 1, so then I have 39 groups of 1. Okay? And the way that people often often say the rule about multiplying numbers by 1 is that multiplying by 1 doesn't change the number, or 1 times any number is that number itself. Okay? And I want to also mention, as a side note, multiplying by -1. So if you want to think about what it does to multiply by -1, so like -1 times 7 would be -7, and -1 times, say, -4 would be negative times negative is positive, so that would be +4. And so you might think of this, I want to not do that. So like these two numbers are related to each other. How are these numbers related to each other? They are opposites. So another special number that we might think of is that multiplying by -1 is the same as taking the opposite of a number. Okay, multiplying any number by -1 gives you the opposite of that number. All right. So because of this multiplicative property of 1, and by that I mean this one, not the one about -1. The fact that multiplying by 1 doesn't change the number, it doesn't change the identity of the number. We call 1 the multiplicative identity. Okay, it's the multiplicative identity. It's the number that when you multiply by that, it doesn't change anything with multiplication. As another side note, you could ask the question, what number is the additive identity? And what I would mean by that is, what number would you use to add to any number to not change the value? Think about that for a minute. The number is, wait for it, it is 0 is the additive identity. Adding 0 to any number doesn't change its value. All right. So now I'm going to look at doing a few calculations, and again, we're going to try to find 2 different ways to do each calculation. So if I have 12 groups of 12 times negative 100, I could think of this as 12 groups of negative 100. And so I clearly don't have enough spaces on this number line in order to make the right number of tick marks if each one of these tick marks is 1. So instead, I'm going to make, I think I'm going to make every 2 tick marks be 100. So negative 100, I'm going to be going into the left. I'm going to go towards negative, so I'm going to put 0 up here. Yeah. I'm going to put 0 up here, and I'm going to call this negative 100. So there's one group of negative 100. And I'm going to add up 12 groups of that. So here's another group of negative 100 and another group of negative 100. And I'm going to do 12 of those. Adding up 12 groups of negative 100. So this would be negative 200, 300, 400. I'm going to label every 500. Negative 500, 600, 700, 800, 900, negative 1,000. And then negative 1,100. And this would be negative 1,200. Or sometimes we also refer to that as negative 1,200, which makes sense. It's 12 hundreds. Okay, so this is negative 1,200. So you might also think of this as subtracting 100 groups of 12. And I would say adding up 100 groups of something is much less easy than adding up 12 groups of something. So I'm going to stick with the 12 groups of negative 100 here. Okay, so this one I want to say this is subtract, so wait, I should probably say this is adding 12 groups of negative 100. So I can think of this one here as subtracting 30 groups of negative 9, or subtracting 9 groups of negative 30. So again, thinking about this, like, I think I would probably rather add, look at 9 groups of something than 30 groups of something. So again, if I'm adding a negative 30, I would go that way. So if I'm subtracting a negative 30, I would go in the opposite direction. So I should be going 9 groups in that direction of 30. So I believe that I have had seen that there's more than more than 25 tick marks on here. So I'm actually going to put 0 here. And I'm going to label by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 30, 40, 150, 10, 20, 30, 40, 200, 2, 3, 4, 250, 2, 3, 4, and 300. And I actually, in fact, want to move this over. Okay. Because I wanted to show, so there's negative 50. So I wanted to kind of put this up there again. So if this is adding a negative 30, then this would be, oops, negative 30. Then this would be subtracting a negative 30. So I would go one group of negative 30, two groups, three groups, four groups, five groups, six groups, seven groups, eight groups, and 9 groups. So this is subtracting negative 30. Okay, so then the answer would be negative 30 times negative 9 is positive 270. All right. Now, looking at negative 20 times 500, I could think of subtracting 20 groups of 500. Or adding 500 groups of negative 20. All right. Again, I'm going to go with the smaller number of groups, so subtracting 20 groups of 500. So subtracting a 500, if adding a 500 is going that way, then subtracting a 500 is going to go to the left. Okay, so I'm going to put my 0 up here. And I'm going to, let's say I'm just going to call each one of these jumps is 500. So minus 500. And then another one. So this actually kind of brings in a nice little thing of subtracting 20 groups of 500. Every 2 500s is 1,000. So that would mean the same as subtracting 10 groups of 1,000. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I'm subtracting 20 groups of 500, and I'm just going to label every 2. So there's negative 1,000, negative 2,000, negative 3,000, negative 4,000, negative 5,000, negative 6,000, negative 7,000, negative 8,000, negative 9,000, and negative 10,000. Okay, so that would say that subtracting 20 groups of 500 would give us negative 10,000. All right. All right, so 19 times negative 1, I could think of adding 19 groups of negative 1 or subtracting one group of 19. Either way. So we're going to be going to the left, so if I do 19 negative 1s or subtracting one group of 19, I'm going to put my 0 here and I'm going to start labeling every 5. Negative 5, negative 10, negative 15, negative 20. So we can see that subtracting one group of 19 once, or you can see adding up 19 little negative 1s, okay? And I'm gonna go ahead and not put those there. All right. So looking at this one, I have a whole bunch of multiplication. Because multiplication is commutative, I can actually do this. I could do any sort of pairings I want as I go along. And so I'm actually going to see, like, I really like this 5 times 20 here. And another thing to think about is I can go, well, what sign is this going to be? Is this going to be a positive or negative result? If you think about the process, essentially, since I can put these two negatives together, they would make a positive, right? And then the rest of the numbers are positive, so it'd be like multiplying just all positives. So this is the same as multiplying, so I can say just from looking at this that the result is positive. Because these two negatives will cancel each other out and make a positive. And with that there, then I can just multiply the values and not have to worry about the sign until later. Okay? So now I can see this just as 3 times 12 times 5 times 20 times 8. And I'm going to go ahead and I really like that 5 times 20, so that part is 100 times 8. So again, I've already taken care of the signs, so I'm not looking at the signs anymore. I'm just saying they're all positive numbers now. And doesn't really matter. So I could say this is 36 here, and then this is 800. And 36 times 800, well, actually I kind of, in many ways, I don't really want to do that. I want to do times 8 times 100. So 36 times 8, let's see, 36 times 2 is 72 times 4. I'm trying to do this mentally. I could use a calculator too, or scratch it out stacked ways, but I'm separating that 8 into 2 times 4 and multiplying the 36 times 2. 72 times 2 is 144. So this is a 2 times 2. So this is, and I should keep track of that 100 that's supposed to be multiplied by there. This is then 288 times 100 is 288 with 2 more zeros. Put a comma there, and there is our answer. Okay, so again, you can approach this in several different ways. It is a good idea to kind of scan across here and figure out what the sign is, so then you can just worry about multiplying the absolute values and make sure that in the end your number has the correct sign. Now, and if you wanted to, you could also multiply this straight left to right, like 3 times 12 is 36, 36 times negative 5 is whatever 36 times negative 5 is, and then that number times 20, and then that number times 8, negative 8. So you could work left to right if you wanted. Actually, let's do that and see that it comes out the same. 3 times 12 times negative 5 times 20 times negative 8. So this is 36 times negative 5 times 20 times negative 8. 36 times negative 5 is going to be a negative number. 30 times 5 is 150. 30 times 5 is 150, and 6 times 5 is 30, so this is going to be 180. 150 plus 30. Times 20 times negative 8. So 18 times 2 is 36. This is negative times positive is negative. 18 times 2 is 36, and I have a times 10 here and a times 10 here. Times negative 8. Negative times negative is positive, and I'm going to do 36 times 8. 30 times 8 is 240, and 6 times 8 is 48, so there's 288. So that was 36 times 8, and then I have times 100. Okay, so there's another way of doing it, and we get the same result. All right, so looking at this one, part F, you might start by doing negative 32 times negative 3, and then that result times 6. But I encourage you, again, look all the way across and see what you expect the number to be. Okay, and you might see this in there. What is that going to do to the result? Yep, any number times 0 is 0, so the whole result is going to be a 0. Maybe I should box it like that. The result is going to be 0.